So there's certain problems that we'll come across where we won't be able to solve unless we use logarithms to do it. All right. And so we first have to understand how to change from one form to another form. So one form we have what's called exponential form, and the other one is called logarithmic form. All right, so let's call it. All right, so we'll call this exponential form, and this log form. So exponential form has a base that's carrying the exponent. And so we say b is raised to the x power and equals y. All right, so you wanted to state what that means. So you have a base raised to an x power, the exponent equals y. And then if we want to change that into what's called log form, we're rearranging the letters basically. And you can say that it has a log y with base b equals x. All right. And so these two forms, the forms are different, but the equations actually are equal. So it's almost like a mixed fraction and an improper fraction. You have two different forms. One form is used for certain kind of problems, and other forms used for other ones. But they mean the same thing, really. So when we want to convert from one form to the other, you can kind of think of down, cross, cross. So here we have this 4 to the third equals 64. All right, that's exponential form. If we want to convert it into a log form, the first thing you do is write the word log, okay? Then you bring down the base. So the base is the exponent 4. The 4 is the base. So you bring down the 4 as a subscript, all right? And then you cross the right side number over to the left side, and the left side number, which is the exponent, over to the right side of the equal sign. All right? And then you can go back and forth. So you can go from log form to exponential form and do the same thing. All right, so if you want to go from log to exponential, you're going to bring the base down, right? And then you're going to switch the two numbers across the equal sign. All right, so again, we're just rearranging these terms around. All right, now there's a special kind of logarithm. There's actually two special kind of logarithms. One's called the common logarithm. So that's a log where the subscript or the base of the log is 10. Now, when the base is 10, most of the time they don't write it. They just don't put a number there. And so if you don't see a number, it's automatically 10. All right, so if you just see a log x and there's no subscript, then it's automatically 10. And then we'll be looking at another log later on this week, I think maybe tomorrow, called the natural logarithm also. All right, so the common logarithm, if you don't see a base, always put a 10 there. All right, so let's go ahead and practice rewriting from one form to the other. So 4 through 7, they're all in exponential form, and we're going to convert them into log form. So rewrite it as a log. So the first thing we do is write the word log. Now we're going to bring down the base as a subscript, and then we're going to switch or cross the two numbers, the other two numbers, across the equal sign. So the 9 goes over to the left side equals the 2 goes over to the right side. All right, so log base 3, 9 equals 2 is the way you can say it. All right, we can do the same thing for 5, changing from exponential to log form. So we write the word log. Bring down the base. So the base here is x. And then switch the two numbers across the equal sign. So 7 equals 5. All right, so we can see that in the exponential form, the 5 is the exponent. And when it's in log form, the exponent is equal to the log. Because if the log of 7 equals 5, and 5 was the exponent, that means they have to equal to each other. It means the exponent is equal to the log. All right, number 6, same thing. So we have log base 10, and then 1,000 equals 3. Now, because it's base 10, you can leave it, or this is the same thing, log 1,000 equals 3. Right? So when there's no base written, it's automatically a 10. And if you put a 10 there, then you can get rid of it also. All right, 7, let's see, log base 4, and then switch the 16 and the x across the equal sign. All right, so now we're going to do the reverse. We're going to change it from log form into exponential form. All right, so again, think of that down, cross, cross. So we bring down the base first, and then switch the two numbers across the equal sign. So the 2 becomes the exponent, equals 16. All right, so 4 squared does equal 16. All right, let's do 9. Here we have 2. We're going to raise it to the negative 3 power, equals 1 over 8. All right, and then 10x to the second power equals 36. Then 11, since there's no base, it's automatically 10. So it's 10 to the x power equals 100. All right, so now we're going to go ahead and evaluate exponents. Now, this is where the exponent sheet comes in. Now, I'm going to show you the long way first, but then you're going to actually do all the work really in your head. All right, so if we take this number 12, if we take a log and we set it equal to some variable, we can change it to exponential form. All right, so in exponential form, this would be 2 to the x equals 8. Okay, log base 2, 8 equals x is 2 to the x equals 8. Now all we have to do is figure out what can we put in for x, what number can we put in for x so 2 to that power equals 8. Well, you just go to your exponent sheet if you don't know, go down to the 2's column and figure out which exponent is equal to 8. So what is it? 3, right. So x equals 3. So that means that log base 2, 8 equals 3. So what you're doing is, instead of having to write this out every time, you can do that. You're really going to do it in your head. So when you think of this in your head, always look at the base first and ask yourself 2 to what power equals 8. That's all you're looking for. We're looking for the exponent. Okay, and that's what this says right here. 2 to what power equals 8. You're just doing this part in your head. All right, so 13. All right, so we're going to ask ourselves 4 to what power is 16? It's 2, right. So log base 416 equals 2, because 4 squared equals 16. All right, now anytime you have a fraction, you're going to have to think negative numbers, negative exponents. All right, so 4 to what power would equal 1 over 16? Negative 2, right. All right, kind of think of 4 to what power 16? Well, it's 2, but to get the fraction, you have to put a negative on it, so it's negative 2. All right, 15, log base 381. What would that be? 4, right. 3 to the 4th power equals 81. All right, how about 16? 3 to what power is 1 over 9? Negative 2. Yeah, we need a negative. So if it just said log base 39, then it would be positive 2. But because of the 1, 9, it has to be negative 2. All right, 17, log base 864. 2. Okay, 8 squared is 64. All right, 18, 1/2 to what power would equal 8? You can kind of think of it the same way as how we did 16. Kind of think of Well, 2 to what power would equal 8? 3, right? But we know that 1/2 to the third is 1/8. So how do we get it to be 8 then? Okay. So again, you can just change it to an exponential equation. Well, when you have a fraction, you could take this 2 and bring it up. And because it has a 1 right here, an exponent 1, if you bring the 2 up, it becomes 2 to the negative 1. Remember, if you switch places, top to bottom, bottom to top, it changes the sign of the exponent. All right? So if we have a 2 to the first down here, you can bring it up to the top and make it 2 to the negative 1. All right, so we have 2 to the negative 1 to the x equals 8. Well, we can multiply those together. So that's 2 to the negative x equals 8. So let's say that negative wasn't there. 2 to what power would equal 8? 3, right? So 2 to the negative x equals 8. So what number can I put in here for x? So 2 to that negative number would equal 8. Negative 3, right. If I put a negative 3 for x times the negative that's in front turns to a positive 3. And 2 to the positive 3 does equal 8. So x would have to be a negative number. It has to be negative 3. So one thing that you can recognize is if this is a fraction, again, think of 2 to what power is 8. It's 3. Because this is a fraction, you need a negative number because you need the reciprocal. Right, so it's going to be negative 3. All right, number 20, log base 525 equals what? 2. 21, log base 327, 3. Number 22, log base 6, 216, 3. 23, log base 216, 4. Number 24, log base 9, 1, 0. Remember, anything to the 0 power is going to equal 1, so we're asking ourselves 9 to what power is equal to 1? It has to be 0. Number 25, log of 100, 2. Okay, remember, there's a subscript 10, so we're asking ourselves 10 to what power is 100? It's 2. All right, 26, log of 1 over 1,000, negative 3. 27, log base 4, 1 over 64. That's negative 3 also. 28, log base 6 of 36, 2. 29, log base 8, 8. What is it? 1, yeah. 8 to the first power equals 8. All right, 30, log base 2, 0. All right, so this actually doesn't exist. It's undefined. There isn't 2 to a power that'll ever equal 0. There isn't an exponent. And same with 31. It's undefined also, because there isn't an exponent 2 to a power that will ever equal negative 4. All right, so this is really important right here. Logs can only be evaluated for positive numbers. You can't take the log of 0 and you can't take the log of a negative number. It has to be positive.